Hello, it is me, Despaigne. I come from DuPont Manual High School, and I am in the 10th grade. Now, the project's title is On the Dirt for 5 Seconds. Now, the reason I chose this project and what it's all about is as follows. Basically, I chose this project because every day, basically, even in your own household, you see your family members, your friends, co-workers, etc. drop food on the ground and pick it up real fast and say, hey man, it's just been 5 seconds, so it's okay. And you know, the problem with that is that, first of all, that's pretty nasty because you don't know what's been on that floor. And second of all, what's on that floor is a lot of bacteria, and when you pick that food up and put it in your body, you could be ingesting a lot of harmful bacteria that could be detrimental to your biological system. So, the hypothesis of this project was pretty straightforward. Basically, the longer that food is on the floor, on the ground, or wherever, the more bacteria that will accumulate onto the piece of food. So it's pretty straightforward, common sense, really. So, to test this theory, I decided to have 5 different samples of varying in time, varying in location. The way I would get the samples is I had sterile swabs, and I had apple pieces, and I would drop the apple on the floor for the amount of time in the correct location, take a quick swab of it, put it in a bag, and then put it on a petri dish, and put that petri dish inside of an incubator. So I did that 5 times, 5 different samples, 3 different locations, 3 different times. Okay, so the 5 different samples are right here. These are the pictures, and I'll tell you about them right now. So, okay, let me start off by telling the 3 different locations. The 3 different locations were right here on the kitchen floor, which is probably the most common place for you to drop food. The living room floor, which is probably another common place. And then lastly, this one was more of a dramatic effect. The front door, where a lot of people step in and out constantly throughout the day. So 2 samples came from the kitchen floor. One was for 3 seconds, one was for 10 seconds. And the same thing was for the living room floor. One was for 3 seconds, one was for 10 seconds. And then for dramatical effect, again, to see how much time actually affected it, I put the sample that was on the floor, on the front door floor, I put it there for 20 seconds. So when I put the samples on the petri dish, of course I kept everything very sterile, very clean, very professional, if you would say. I wore gloves and everything. When I put it in the incubator, and at first I left it in there for 3 days, but in the 3 days, I guess I have a clean house or something, and the bacteria didn't grow enough, so I decided to leave it in there for 4 more days. So basically it was in the incubator for a week, but the incubator was only turned on for 5 of the 7 days because of the weekend and school policies and stuff like that. So, alright, let me tell you about the samples now and what evidence I got from it. So the first sample, I'm gonna refer to these as samples. The first sample is right here. It was one that was dropped on the kitchen floor for 3 seconds, and there was only 1 bacteria colony, approximately half a centimeter in diameter. And since I wasn't able to get samples of the actual bacteria and to test it in the microbiology lab, I assume what the bacteria is based on its shape, its form, its if it's concave or convex, and also its edges. So the one that was on the kitchen floor for 3 seconds has one colony about half a centimeter in diameter. It's very round. Looks kind of gooey, and also is white. So as far as I can tell, that is a form of yeast bacteria, which is pretty common in basically anywhere. So that was a 3-second bacteria. The 3 seconds on the kitchen floor. So sample 2 was 10 seconds on the kitchen floor. And this one actually was pretty interesting. It had a very tiny yeast, similar circular, white gooey. But this one was approximately 1/8 of a centimeter in diameter. But there was a big clump right here. And it's fuzzy, green, also circular, and that appears to be some type of mold bacteria. Sample 3 was the living room. For 3 seconds. And this one actually formed a really interesting type of bacteria, completely different from any of the other ones. So I'm not sure if that was a special spot or something. I'm not sure. But it looks kind of like, I'm not sure, cauliflower with rugged edges, white, very sporadic, basically. It looks kind of like a brain, maybe even. And from what I can tell, the form is like a rhozoid, something like that. I'm not sure how to pronounce it, but yeah. The 4th sample was on the living room for 10 seconds. The living room floor for 10 seconds. And it also just had one colony of the yeast bacteria, circular, round, white, gooey. And this one actually was a little bit more yellow, but still the same thing. And interestingly enough, the one in the front door for 20 seconds had 5 colonies, all measuring around half a centimeter in diameter. And they were also yeast, white, circular, gooey looking bacteria. So I was very confused at first because the data collected from these 5 pictures, the 5 petri dishes, do not coincide with my original hypothesis, because even though this one was on the living room floor for 7 extra seconds, it had one colony which was half a centimeter in diameter, but this one, which was on the floor for 3 seconds, had a large, about 2 centimeters in diameter, and it was a completely different type of bacteria. So that was extremely interesting. So according to this data, at least, the amount of bacteria that gets on the food is not correlated to the time. So realistically, the 5-second rule should be more like the split-second rule, because the bacteria gets on the food so quickly that really time difference doesn't make a difference in the amount of bacteria that you have in your body. Of course, it will, like if you leave it on for like hours and stuff. Of course, more bacteria will get on, but in the short term, the extremely short term, and the amount of time that it takes you to react and pick up the food, it doesn't really matter because the bacteria is already on that food instantly. So now, the reason this is important is because even though none of these bacteria are necessarily lethal, there are certain bacteria that are found in everybody's home that could be horrible for your body. Now, even though it took these samples 7 days or 5 days with heat incubating to grow, in your body it would be a lot quicker. So those 5 days that it took in an incubator would be accelerated to maybe couple hours a day, 2 days maybe. And the reason is because your body is warm, it's moist, and it has a lot of nutrients that the bacteria can easily feed off of. So yes, don't drop your food on the floor, pick it back up and eat it. You could get a weird looking bacteria like that inside of your body, and you do not want that. Thank you for coming to my presentation. See you next year.